Good morning, my dear students. Today we are going to wind up the chapter with a few numericals based on the chapter sound. Alright. The very simple numericals, we are going to deal with very simple numericals. The formula used here will be just two formula. One is velocity is equal to, or speed is equal to, frequency into wavelength, one formula, okay. And the second formula is again for velocity, that is equal to distance divided by time. So on basis of the given question, the situation, we are going to apply these two formula, okay. So let's start with the numericals. For reference of the questions, you can have a look at the book, page number 181, okay. Let me read out the question to you. The first one, it is solved examples from your book. The first question, a bat can hear sound of frequencies up to 120 kilohertz, okay. So frequency of sound is given. The question is, determine the minimum wavelength of sound which it can hear, and taking speed of sound in air to be 344 meter per second. Alright. So question number 1, given frequency is equal to 120 kilohertz. You need to convert this into the SI unit, that is into hertz. So 120 into 1000 hertz. Alright. So 120,000 hertz. Alright. Or you can write it as 120 into 10 to the power 3 hertz. Okay. Next, velocity is given 344 meter per second. Alright. Now, you need to find out the minimum wavelength. One thing you should know here is that if the frequency is maximum, wavelength is going to be minimum. Okay. Now, frequency is given, velocity is given, you need to find the wavelength. Here you should choose which formula to use here. So you are not going to use this one because distance time is not given. So here you can use the first formula, that is V is equal to F into lambda. Alright. So putting the value of V to be 344, F is 120 into 10 to the power 3 into lambda. Lambda is the wavelength, alright. So lambda will be equal to 344 divided by 120 into 10 to the power 3, okay. You can cancel 344 into divided by 120 into, this would go up with a negative power, so it is 10 to the power minus 3, alright. Now on dividing 344 by 20, the answer you should be getting is 2.87 into 10 to the power minus 3. This will be in meter because it is wavelength and the SI unit of wavelength is meter. Alright. Or you can write, instead of meter, you can do away with this power minus 3 because the term for 10 to the power minus 3 can be replaced by milli. Okay. So it is 2.87 millimeter. So bats can hear sound of frequency up to 120 kilohertz and wavelength starting with 287 millimeter. Okay. That is the solution for question number 1. Okay. Coming to the next question. Number 2. Ocean waves of time period 10 second have wave velocity 15 meter per second. So, time period is always denoted by capital T. The time period for the waves is given to be 10 second. Alright. This is number 2 and this is the given data to you. Okay. And velocity is equal to 15 meter per second. So these are the things given to you. You need to find the wavelength of these waves. Alright. Now to find out the wavelength, you will use the formula V is equal to F into lambda. Since frequency is not given, I can use one more formula for frequency, that is equal to 1 by capital T, because we know the value of T. Okay. So V is equal to, in place of F, I can write 1 by T into lambda, and your task is to find out the value of lambda. So lambda, that is wavelength, is equal to velocity multiplied by time period. Okay. Now velocity is 15 meter per second. I can write it this way, into time is 10 second. I can cancel second. Okay. So wavelength is equal to 15 into 10 is 150 meters. So the wavelength of the given ocean waves is 150 meter. Okay. Now second part, the horizontal distance between a wave crest and its adjoining wave trough. Now this crest and trough are the maximum and minimum locations of the wave. So this is crest, this is trough. Alright. Now if I draw the wave again, now the distance between one crest and the other crest will be equal to one wavelength, that is equal to lambda. But the question has asked you the distance between the crest and trough, so that means it is only half the distance of this total distance. So this is equal to lambda by 2. So the horizontal distance between the crest and its adjoining trough, so that means immediately after this crest, this trough is coming. So it is just half the wavelength. So it is equal to lambda by 2, part 2. Okay. Lambda was found out to be 150 meter by 2, that is equal to 75 meter. So this is how you solve numericals related to crest and trough. That means distance between crest is one wavelength, but distance between crest and trough is half a wavelength, or you can say distance between trough and trough is one wavelength, distance between a trough and its adjoining crest is equal to half a wavelength. Okay. Now next question, number 3. A wave pulse of frequency 200 Hz. So for question number 3, given frequency is equal to 200 Hz. Okay. On a string moves a distance 8 meter in 0.05 seconds. So here distance is given to be 8 meter and time is equal to 0.05 second. Okay. Calculate the velocity of the pulse. Alright. Now to find out the velocity, you cannot go for this first formula, that is F into lambda, because you do not know the value of wavelength. Okay. But you can use the alternative formula, that is the basic formula, velocity is equal to distance by time. So I can write velocity is equal to distance is 8 and time is 0.05. You can do it, 800 by 5. Okay. So the velocity of the pulse is 160 meter per second. Okay. Next, the same question has given you a second part, the wavelength of the wave on the string. Now with the help of frequency and the velocity that you just calculated, you can easily find the wavelength. Velocity, this is part B, velocity is equal to, the answer was 160 meter per second. Okay, you need to find wavelength. The formula to be used is equal to V is equal to F into lambda. V can be replaced by or. Lambda is equal to V divided by F. Value of V is 160. Value of F is 200. Okay. On cancelling, you will be getting lambda to be equal to 0.8 meter. Okay. So here we have applied the alternative formula, and from the given calculated value, we have applied the value to be used on this formula. Okay. So these are the different ways in which you can solve the numericals. Okay. Next. Number 6, okay, the speed of sound in air is 330 meter per second and in water it is 1650 meter per second. So, question number 6, speed of sound in air is given to be 330 meter per second, and at the same time the sound travels in water with a velocity. You know the speed of sound is faster, more in water than in air. So it is 1650 meter per second. Okay. Now it takes 2 seconds for sound to reach a certain distance from the source placed in air. So one situation has been given to you that if you make a sound in air, okay, it takes 2 seconds for the sound to reach a certain distance for the source in air. Okay. So the time taken by sound to reach a certain distance in air is 2 seconds. Alright. Find the distance. So with the help of this you can easily find the distance with the formula velocity is equal to distance by time. We are not dealing with the velocity in water right now, we are just dealing with the velocity in air. So velocity is, or I can simply find d is equal to velocity into time. I can just put the suffix here aa because it is in air. V is 330 into t is 2. Okay, on multiplying you get 660 meters. So the distance to be calculated is found out to be 660 meter. Okay. Now the second part of the question is how much time will it take for sound to reach the same distance. So here same distance means the distance for sound to be covered is 660 meters. So the distance here, that is d in water, is also equal to 660 meter. Okay. Then how much time will it take for sound to reach the same distance when the source is in water? Now since the speed is different, the time taken by the sound to reach the same distance is different. Okay. So we are supposed to find out that distance with the help of the formula V is equal to distance by time, or time required for the sound in water can be written as d divided by V in water in water. Okay. Distance is 660 meter and velocity in water is 1650. Okay. On calculation you will be getting this time to be equal to 0.4 second. Okay. So with reference to air we found out the distance. Okay. And the same distance has to be covered by the sound in water. So it will take a different time. If you notice it takes shorter time because the velocity is more. Alright. To cover the same distance it takes 0.4 second. Alright. So these are the types of numericals. These are very simple numericals. Okay, after the reduced syllabus, we are only dealing with the simple numericals. Hope you have understood well and see you in the next class. Thank you.